Hello. Today we're going to talk about Kirchhoff. Kirchhoff rule. So Kirchhoff has two rules that we will talk about. So one's called loop rule. One's called junction rule. So why do we need this? So we can use it to come up with the equivalent resistance. And we can deal with the complicated, more complex circuit. Okay. So first, loop rule. So loop rule is also called voltage rule. It's an energy conservation rule. So no surprise. Here again, energy conservation. Okay, so what does that say? Let's say if I have a loop. So something like that. Say V is equal to 10 volts. And say R1 is equal to 1 ohm. And say R2 is equal to 4 ohms. Okay? So we know how to do this by using just Ohm's rule. So we know that I will be equal to 2 amp. Okay, because I is equal to V divided by R total. And that's 10 divided by 1 plus 4. So that's equal to 2. So 2 amp. But we can also use in Kirchhoff rule. So Kirchhoff rule says the following. So I'm going to clear that. So Kirchhoff rule says, so that one more time. Right, so R1 equal to 1, R2 equal to 4, and V equal to 10 volts. Okay. So loop rule. So the summation of all the voltages, right? All the voltage differences around a loop, okay, around a loop is equal to 0. All right. Remember, electric potential is energy per charge, right? So that's why we call it energy conservation rule, because we are talking about the energy that's around a loop, and we add them all together, it's a 0. It's a constant, and the constant is a 0. So the conservation is conserved in that sense. So let's talk about that, right? So if we start from here, okay, so let's call that A, right? You start from here. So then the first one is, so this is minus, that's plus. So you have the first one go from A to B. So A to B, basically you go plus 10 volts, right? And you come over here, the current is here. So let's assume the current is I. So then you would then minus, okay? So you say minus, okay? So now your loop is going this way right now, right? So your minus R2 times the I, okay? And then you keep going, you say, well, now I'm come to here now, right? Come to here now. And this is the same current, right? Because it's in the same loop. So the current is the same. So you minus R1 I. And now you're back to the A now, right? Okay. So this is from A to B. And this is from B to C, right? This is from B to C. And this is from C to A, right? So C back to A. So that's a loop right there. A, B, B, C, C, A. Now back here. And that's equal to 0. Okay, so what does that tell us? That says that 10 volts is equal to R1 plus R2 and I, right? So this is basically combining the Ohm's law, right? Ohm's law, and then also the series, right? The series, so the resistor in series, right? Together. Okay, so then you have that, then you can also then solve for your I now, which is then equal to 10, and then 1 plus 4, which is equal to 2. Okay, so that's a loop rule. Now let's talking about the junction rule now. So 2, junction rule. The junction rule is also called the current rule. Current means the I, right? The I, current, okay, current rule. And then it's also called the charge conservation. Conservation of charge. So it's a lot of conservation rule. You see that? That's what we've been dealing with. It's conservation of charge, mass, momentum, energy, right? Mechanical energy, right? That kind of stuff. Okay, so now what is it? So let's say if we have a loop like that. Okay. Now this is V, and that's equal to 10 volts. And let's say we have this one here, R1 equal to 1. Okay. Let's call that 2. Okay. Equal to 2. And R2, let's call that 1. 1 equal to 1 ohm. Okay. All right. So we know if we do the equivalence, that 1 over R is equal to 1 over R1 plus 1 over R2, which is then equal to 2. So it's 1 over 1/2, right? So R is equal to 1 over 2, right? Right. So that's the equivalent. Okay. So we know the I will be, right? The I will be 10 divided by the R, so which is 20 M, right? So that's 20 M. Okay. Now, what is the junction rule? Junction rule says the following. Okay. So I'm going to call this I here, call that I1, and call this I here, call that I2. So I'm going to pick this junction right there. Okay. So that's my junction. Okay. So the junction rule says that all the summation of all the current, right, entering into your junction, right, into a junction, it's equal summation of all currents, right, out of the same junction. Okay, all right. So I'm gonna erase it, and we will do that example, right? So basically, we pick this junction here, right, and we call this one here I1. No, we call that I, right? And we have this one here, we call that I1, right? And here's I2, okay? And then come back, right? Okay, and this is V equal to 10, and this is equal to 1, this is equal to 1. Okay, so we're saying that I is equal to I1 plus I2, right? Because that's what, when we apply this rule, entering this junction, we have this one here. There's only one, right? So when we sum them together, sum all the I together, right? This is the entering, right? Entering. It's equal summation of exiting, right? Exiting the junction, right? Okay, so the entering, there's only one, so just I. And exiting, this one is the leaving, right? So leaving the junction, I1, leaving the junction, I2, so you add them together. So this is equal. That's what we're saying. So what is this one here? This one here is the Kirchhoff, right? This is the Kirchhoff junction rule. So how is that useful? So that just says that the current that comes in will be splitting into different amount, but whatever amount we add them together, they are the same. So you can see this is the charge per T, and this is the charge 1 per T, this is charge 2 per T, right? So you can see you are basically saying the Q is equal to Q1 plus Q2, okay? So charge conservation. Okay, so what you are basically getting is you're getting an independent equation, okay? hopefully, right? Sometimes some of them are redundant, okay? For example, if you put it here and then you do that, then you're going to come up with I1 plus I2, which is entering. And then leaving is this I here is equal to I. So that's redundant, right? Okay. And you can also apply the loop rule here, and then you'll come up with another equation, right? Another equation will be here, and that will be another independent equation, okay? And this is from the loop rule. Then you can use these two equations to solve the problem. All right. So we're not going to do that in this this lecture. We're going to do that later. Okay. So that's just a quick explanation of Kirchhoff loop rule, also called voltage rule. And